We do a debate class, everyone can get up there and that'd be fun. All right, I'm not qualified for that stuff. So last class, we were talking about lines, right? And so what I want to do is start off with an example. Let's do x plus 8y equals 8, just to recall what we did last time, all right? And I'm going to go fast through this. If we were asked to graph this linear equation in two variables, we would do the intercept method, right? So first we go grab maybe our x-intercepts first. To do that, we set y equal to 0, right? And we get x is 8. Oh, by the way, if you did not turn in the quiz at the end of class last time, you have that. I'll collect it now. Anyone that didn't turn it in? No? Everyone turned in? Okay. I didn't grade them because I was waiting on the people today, but I guess we have no. Okay. I'll get those back to you next week. Okay, everyone agree? Yes? Okay, for the y-intercept, we set x equal to 0. We go up here. If we do that, we get 8y equals 8, which means y is equal to 1, right? Okay, so then we go graph this. I'm going to be somewhat careful in the way I graph this. My x-intercept is 8. 1, 2, 3, 4, 5, 6, 7, 8. Right here I have a dot. And my y-intercept is 1. Right there I have a dot. And then I draw a straight line through here. And I'm going to do this with my straight edge here. All right, so that's what last class was about. And then we also did like vertical lines and horizontal lines. Today we're going to take a different approach to graphing lines. But to get to that approach, I want us to notice something on this line. Remember, this line really consists of a bunch of points, right? That's really what it is. So let's say that I was going to try and get from this point, like let's say I knew that point was on the line, and I wanted to get to this point, which is also on the line. Then to do that, I could move over a certain amount and then down a certain amount, right? Or I could go down a certain amount and then over. It doesn't matter which order I do those, as long as I have some up and down, some left and right. So what we like to look at is what we call the slope of the line. That's the pitch of the line. And that slope is defined to be the rise, which is your vertical displacement, divided by your run, in which that is your left and right displacement. So if I want to go from this point to this point, how much would I rise by if I want to get to here? So I would actually have to go down 1, right? So I'd go down 1, so my rise would be down 1 is negative 1. And then run would be left and right, and I would go 1, 2, 3, 4, 5, 6, 7, 8 places to the right. And that direction is positive, so I do that, right? So by definition, the slope of this line is negative 1 over 8. So let me see. What if I rewrote this fraction as 1 over negative 8? Is that the same fraction? Having a negative up here, can I move the negative down here, and is it the same thing? No?
Can we show you the other side of the line?
Okay, so I'm not saying is it the same point. I'm saying is this number the same as this number? Are those two numbers the same numbers? So this one is the negative 1 over 8, right? That's a negative number. And this one is also negative 1 over 8. They're both negatives. When you have a negative on a fraction, it can be on the top, or it can be on the bottom, or it can be out front. They're all equivalent. So this number is equal to this number, and it's also equal to this number. Okay, so these are all the same, all right? So that sounds like y'all weren't clear on that, but let's be clear now. If you have a negative on a fraction, the negative can be on the top, or on the bottom, or out front, and they're all the same, all right? So if this number is the same as this number, then that means that the slope of the line is also rise 1, run negative 8, right? Which means that I could go from this point back to that point by going a rise of 1 and a run of negative 8, right? And then to get to any other point on this line, I just continue to do that. Rise 1 over 8. And I would land on that line. Or I could rise 1 again, go over 8, and I would land on another point on that line. So no matter where I am, if I start anywhere on the line and then use that number, I will be able to generate more points on the line. Does that make sense? So our goal today is to graph this line, okay? We're going to try and graph this using what's called the slope-intercept method, as opposed to the intercept method. Okay, so let me explain how we're going to do it. All I wanted you to understand before we start was this concept of a slope, like what it is, how it matches up with the picture. So for the slope-intercept method, this is our second method. There's only 2 methods for graphing lines. For the slope-intercept method, our goal will be to write the equation as y equals mx plus b. That's it. That is our goal. In other words, we will want to just solve for y. So let me explain with this example we have up here. Okay, with this example, if I said to try and graph this by using the slope-intercept method, then what you will do is try and just basically take that and solve for y. Try and get y by itself on one side of the equation. So if I ask you to get y by itself on one side of the equation, what would be the first thing that you would do if you want to get this by itself? We get rid of the x over here, right? So we subtract x from both sides. So I subtract x here, I subtract x here. Over here it goes away, we get 8y. And then on this side, what's 8 take away x? Well, we don't know what x is, right? So we can't, it's just 8 take away x. So I'm going to write that this way. Negative x plus 8. So notice instead of writing it 8 minus x, I wrote it as negative x plus 8. And the reason I did that is because my goal is to make it look like this, which is a number in front of x plus a number by itself. Right? So right now, do I have a number in front of x? What's the number in front of x? Negative 1. What's the number by itself? 8. Okay, so that's what we're going for. The only problem is we don't have y by itself. It's 8 times y. So how do we get just y? Divide by 8. And that means we divide this by 8, this by 8, and this by 8. So if I divide by 8 here, divide by 8 here, divide by 8 here, I get y equals, now this right here is a little bit tricky. Let me write it this way first, the same as this. Right? And 8 over 8 is 1. Now when we write this is correct to write it that way, but we want it to look like this. So we want a number separated from the x. So when I write this, I'm going to write negative 1/8 x plus 1. Okay, so all I did was just took this x and kind of slid it off to the side. It's being multiplied. And now do you see that it looks like this right here? Yes? Okay, now what we've done is we've taken the equation and we have written it in what's called slope-intercept form. Okay, so what is the value of having this? Like, why is this getting it to this so important? What is it about this that allows us to now graph the line, right? Like, what is it? Well, I want you to notice something about this. Right now, if I ask you what the y-intercept would be, how do we find y-intercepts? You replace x with 0, right? So right now, if it looks like this, if I tell you to replace x with 0, what's the y-intercept? 1. How are you getting that? Place that x with 0, right? And this number right here is what's left, right? If I put 0 here, I get y equals 1. With me? So go back to this form over here. If I asked you to find the y-intercept of this, what would you always get? What would be your y-intercept of anything that looks like this? B, right? This number B right here. Because if I ask for the y-intercept, x will be 0, that'll be gone, and y will always equal b. So if you can take an equation, write it like this, that number will always be your y-intercept, always, always, without fail. So if we can solve for y, we know right now, without doing any work, okay, without doing any work, we know that this number right here is the y-intercept, which means we have 1 point on the line, don't we? We have 1 point on the line. The only other thing we would need to draw the line would be the slope, which would tell us like rise over run to get to another point. And do y'all see it there? Remember, this same line I started with. What was our slope? We had -1/8, right? And that's this number. And it will always be that number. The number will always be the slope. Okay? So if we can get our line to this form, we should be able to graph it pretty easily. Let's go ahead and do that now. All right, we're going to graph it. So if you were asked to graph that line, use the slope-intercept form method, you solve for y. You know the y-intercept, you know the slope. So remember, to graph this, I have to start at a point that I know. And what point do I know? Is on this line for sure? The y equals 1, right? That's my y-intercept. I know that just by looking at this. So all I'm going to do is go on my y-axis. I'm going to go to 1. I'm going to put a dot. And then from there, to get my second dot to draw my straight line, I just use this. And this means to get to another point, I'm going to go, what? Down 1 and to the right 8. So if I start at this point, go down 1 and to the right 8, 1, 2, 3, 4, 5, 6, 7, 8. I will have my second point, and then from there, I can draw my line. So I wind up doing the same exact thing that I did before. I draw the same exact line. So I think if you sit and you go through this, you might say, well, this is harder to do this. You know, the other way was fine. I was happy with that, right? Like just use the method from last class. You should be equally comfortable with both methods, all right? So today's going to be all this method. All right, let's do a new one. Are there any questions on this? Start with an equation, solve for y, make it look like this, draw the picture. All right, let's draw -4x plus 3y equals 15. And for this, I want you to use the slope intercept. I'm going to write slope int method. All right. We'll pick up where we left off last class. Elenia? No, Elena. I got it right? Look at me. All right, Elena. So what's our first step? If I'm telling you to use the slope-intercept method, the first thing we're going to do? Move the 4x over. So add 4x to both sides. So what would the next line be?
3y equals 4x plus 15.
4x plus 15. Good. Everyone good with that? And then you want to keep going?
Divide by 3.
Divide everything by 3. So divide 3, divide 3, divide 3. These will go away, become a 1, so we'll have y equals. Now, how did I say I would prefer you write this here? Like that? So with the x, yeah, just slide it out. So 4/3 x, right? And then plus, this is a nice number, so plus 5. Right? So we've solved for y. Now, does that look like y equals mx plus b? Okay. So what's the slope of this? What's the slope of this line, Heidi? Where's Heidi?
Is it 4 up and then 3 to the right?
Yes. So you're saying the slope is the 4/3 number, right?
Yeah.
So that means we're going to go up 4 to the right 3. So we're going to go up 4. We're going to go to the right 3. Okay. What's the y-intercept, Heidi? 5. All right. So it's 5. So when I go to draw this, Heidi, the first thing I put on here is what? What's the first thing I do once I draw my x and y here? The y-intercept. Always start with the y-intercept, okay? Because you have to start at a point, and then you can use your slope. So I'm going to go 5 units, 1, 2, 3, 4, 5 units on the y-axis, put a dot. It will never be on the x-axis, okay? When you're using this method, it will always be on the y. And then from there, you said up 4, right 3, right? So I'm just going to go up 4, 1, 2, 3, 4, 2, 3, 4. To the right, 3, 1, 2, 3, right there, and I will put a dot there. Now, this next part is not too important. Macy, where's Macy? Macy, what can you tell me just by what we've done? Can you actually tell me what this point is, like its x and y coordinate? Can you tell me how far over and up that point is? So how far over this way did we go? To the right, we went how many spaces? We went 3. So this is like 1, 2, there's 3 here. And then how high up are we now? 9, right? So we don't need to know that, okay? But we could pretty easily say that that's the 0.39. Yes? Okay. Now all we have to do is draw a straight line. And once you draw a straight line, we're done. Andrea? Where's Andrea? Andrea? No? No Andrea? Kristen? So what if you were going to kind of describe the graph we got here compared to doing it the other method from last class? Like, do you see any like big differences in terms of like the information we have here compared to what we had in the other one?
In the other one, you pretty much only find 2 points, and in this one, you can keep going.
Yeah, we could keep going, right? So in this one, we could keep using the slope to get more points, right? So we can get more points from this one. But does this one give us the x and y intercept?
If you work your way down.
If we work our way down, maybe, right? So let's see. We have a slope of what? 4/3. So that means up 4 over 3, right? Could I get back to here? Okay, how could I get to that point? Down 4. What's it? 1, 2, 3, 4, and then over 1, 2, 3, and I'm like here, and then I have to do it again, right? But if I do down 4 and over 3, I'm not gonna find that, am I?
No.
You see what I'm saying?
But you can go the other way. I don't know how you would phrase it mathematically.
Yeah.
But you would go this way and then down, right? You could do that.
From this point, we could go over and down. If we do, that would be over 3, down 4 still.
And then wouldn't you still be able to go over again?
Over 3 and down 4 would put us here. Yeah, so, I mean,
I thought I understood this method, but maybe.
no, you do. All I'm trying to get y'all to see is, look, in the previous method, we had the x and y intercepts, right? We had those, and we draw our line. In this method, you have the y-intercept, you have another point, but it doesn't guarantee you the x-intercept. Like it may turn out that you go down and over and you land on it, but it's not guaranteed. All right? And we could get it, but it's not worth our time to go and show how that would happen. But so advantages, I think the advantage of this is if somebody just puts that in front of you, right? Like if I give you a problem on the test and I say, graph it. Like, there's no work, right? There's no work. You just go straight to the graph, okay? So that's the good news. The bad news is that you're not guaranteed to have the x-intercept. So the only way to get it would be to do what we normally do when we find an x-intercept, and that is replace y with 0 and solve for x. And then you could go find the x-intercept. So there might be an additional step there. All right? Okay, let's do another one. This one I'm going to make not so nice. Things have been pretty nice up to this point. Yeah. So I think on this one you'll see one of the downfalls to this method. All right. Okay, so the fractions right away, you're not happy about that, right? Okay, what's our ultimate goal? If we're going to use this slope-intercept method? Get y by itself, right? Okay, so we have some options here. Christine, if you were going to solve this for y, what would you do first? And there are multiple ways we could go about this.
Thank you. You move the y over.
This y, we want this by itself, right? So just leave it here, right? Leave this one here. Let's get this one over, right? Yeah, so move that over. Okay, so does everyone agree that okay, now, could I clear fractions? I could do that also. Like if I didn't want to work with the fractions, I could get rid of the fractions. But moving the 1/2 x to the other side, you'd subtract it on both sides, right? So we would have 3/5 y equals, now when you subtract the 1/2 x, it goes to the other side as minus, and then we still have plus 3/4 here. Okay. Everyone agree? Caroline?
Yes.
Okay, so Caroline, yeah, what now?
Could we clear the fractions now?
Yeah, sure, you could clear the fraction. Do you want to do that? I'm okay with that. So if you were going to clear the fractions, you would have to look at all the denominators and figure out some number that's a multiple of all of them.
20 is the greatest.
20, yeah. So 20, we multiply everything by 20, okay? So we'll multiply this side by 20. I don't need those parentheses, but I'll put it there. And then this side, we're going to multiply by, oh, I don't know why I did that. Multiply this side by 20. Okay, so this should help us clear some of these fractions out. When I multiply here to here, right, that 5 goes into the 24 times, and then that 4 hits the 3 and becomes 12. So we should get 12y here. And then here on the 20, we have to distribute through to both. So Caroline, what do we get here when we do 20 times this one?
Well, 2 goes into the 20 10 times, and we multiply that with a
Negative 1.
10x.
Negative 10x, good. You want to keep going? This one?
And then 4 goes into 25 times, and multiply that by the 3, and we get plus
15, good. Okay, so that looks a little better, doesn't it, than when we had before? Okay, so since this was your idea, we'll stick with you here. So we've cleared the fractions. Now, trying to get y by itself, so what would you like to do?
Divide all sides by 12.
Yeah, divide by 12. We divide by 12 and we'll have y, right? So let's do that. Divide 12, divide 12, divide 12. Everything gets hit by 12. And, okay, 12 over 12 is 1, so we get y equals, okay, that next one, negative 10 over 12x. I'm going to write it that way. And then plus 15 over 12. I'm leaving those as they are right now, but I am going to reduce those fractions. Okay, so I'm going to try and reduce them if I can. 2 goes into both of those, right? So that would reduce to be what? Negative what? 5 over 6 x. And then plus, and on this one, what's the biggest number going into both of those? 3. So we get 5 on top, right? And 4 on the bottom. 5/4. There we go. Now, does that look like y equals mx plus b? Yes? So we have what we wanted. Now we go to graph it. And this is where I think you're going to see that things kind of suck a little bit here. But it is what it is. All right, Damien. Where's Damien? No Damien. No Andrea. Alex.
Yes, sir.
How's it going?
Trying to catch up.
Are those the new?
Boss, yeah.
Oh, they're the bot?
Yeah.
No, okay. I thought they were, what's that other brand?
It's like, well,
Which one? Yeah, no, there's another brand that competes with them. They're about the same level. Okay. Anyway, back to this. What now? If I asked you to graph this line, what would be your first step?
well, I know what the y-intercept.
Yep, y-intercept is positive 5/4, right? Everyone make sure if this was minus, right, you would have to go down, but it's plus. So 5, do you see why this is going to be a little weird? Like where's 5/4, right? So this might be a time where you'd break your calculator out and do 5 divided by 4. And if you do 5 divided by 4, you'll see that it's 1.25. So 1.25 is going to be like, I don't know, somewhere around there. So we're going to have to eyeball this, aren't we? And then from that point, where do we go?
From there, we go down 5 and over 6.
Yep, down 5 and over 6. Do y'all see how that's a little weird though? Because when I go down, like when I go down 1, where am I? I'm like right here, right? So I need to draw some more. This is -1, this is -2, -3. I'm gonna run out of room here. Okay, so when I go down, I need to go down 5, right? So I go down 1, 2, 3, 4, 5. I'm going to be right there, right? So I'm going to put a little mark here. This is where I am. And then I need to go which way?
To the right.
To the right, 6. Now that I can do. 1, 2, 3, 4, 5, 6. That should be pretty easy. 1, 2, 3, 4, 5, 6 puts me about there. Okay, and then I can draw my line through the 2 points. Do y'all see how that was a little weird with the fractions? It can still be done, but it's just slightly strange. And we still don't know what the x-intercept is, right? We know it's there, we just don't know what it is. Any questions on this? Yes?
So for like the beginning,
Uh-huh.
for the 20, you just solved like what the 5 and the 4 kind of comment?
Nope, what 5, 2, and 4. So, you know, you think of all the multiples of 5, 5, 10, 15, 20, 25, 30, right? And then you think of all the multiples of 2, 2, 4, 6, 8, 10, all the way out. And then you think of all the multiples of 4, and you see what they have in common. The smallest number they have in common is 20.
Okay, and then when you distributed it, like for the first one, like how did you do it?
So this is really like 20 over 1 times 3 over 5, right? So there's 2 ways to do this. You can multiply 20 times 3 and get 60, and then divide by 5, and that would give you 12. Or you could do 5 goes into 5 once, 5 goes into 24 times, and then you multiply across 12 over 1.
Okay. And then the same thing for the one.
Yeah, the same thing when we went here and here. And thank you for asking the question, because I guarantee you're not the only one who has that question. All right, we good? Okay, let's take a look at the assignment, the problems that we're supposed to do for this, and see if they all seem within reason. And if they do, then we can move on to the next topic. And you're just going to have to trust me that this slope-intercept method is actually very useful later on, because later on, when we deal with functions, everything's already solved for y. So we don't get the choice in the beginning to do the intercept method. We just kind of we already have this method in front of us, so we want to know how to do it. So for all of these, do you think you could do what we just did? Solve for y, rise over run, plot it, solve for y, solve for y, solve for y. What about this one? This should be a little light bulb in your head from last class. Divide by -3, and we know that this is what type of line? If y is a number, it's horizontal line. And then this one over here, you have just x as a number, that should be a vertical line. So these are 2 exceptions. These are always going to be exceptions to the 2 methods we have. Okay, so yeah, this one's kind of like the one I just did, right? You got a lot of fractions in there, you got to pay attention. Same thing with this, fractions in here, solve for y. Okay, and then these you're just supposed to solve for y. I would just practice graphing them if I were you. And then this, you're supposed to actually put the graph there. Do all these seem reasonable to you? Or do you want me to do another one of these, or how do you feel? Okay? All right, so now let's talk a little bit about we've said that if someone gives us an equation, right? Somebody gives us an equation, linear equation in two variables, we should be able to draw the line. But what if somebody just tells us, hey, these 2 points are on the line, what's the equation? What's the actual equation that goes with that line? And that's what our goal is now. So there's a couple of formulas here we're going to have to use. So the idea is this. So far, if we're given an equation, given a linear equation with two variables, we can graph the line, right? Would you agree with that? We have two methods to do this now. So we should be okay with that, right? The goal now is that if we are given, instead of the equation, we are given 2 points on a line, can we find the linear equation or not? Okay, so that's the idea. Because a lot of times you'll have two data points and you want to know the line that goes through them, instead of someone giving you the line and you finding the points and plotting them. When I say a lot of times, I'm talking more of like real world. Okay, you have you measure something at a certain point in time, you measure something at a different point in time, you have two data points and you want to connect them with the line. So you want to know what the equation is. So here's how we're going to do it. All right. We are going to use the all-powerful point slope formula. All right, so this formula I'm about to put up here is called the point slope formula. Reason it's called the point slope formula is because you can use this formula if you know a point and if you know the slope of the line. If somehow you know those two things, you can come up with the equation of the line. So here's the formula. Y minus y1 equals m parentheses x minus x1. Let me explain what all this is. First of all, m here is just the slope of the line. Okay? And then the x1 comma y1, these two numbers right here, this number and this number, is the point that you have on the line. So remember, I said to use this formula, what two things must you have? A point and a slope. So if you know the point, we'll call it x1, y1, and you know the slope, then you can use this formula. All right? So I'm going to do, my first example is going to be just making sure you understand how to use the formula. Let's do this. So if the point -4, 2 is on a line with a slope of -3, find the equation of that line. So what have I provided you? I provided you a point, right? And I provided you the slope of that line. I'm giving that to you. And now I'm asking you for the equation. So you're just going to go over to this formula and plug everything in. So what is Kayleen? Kayleen? By the way, this is probably not something I should talk about, but you drive that white car? No? Do you drive a white car?
Yeah.
I really like that car. You park it like in the same spot? Because I always go around and I think I've seen you. I really like that car.
Thank you.
Yeah. Okay. I'm not. That sounds weird, like I'm like watching people, but I like the car. And then I saw you either go in or get out of it, and I was like,
A
oh.
lot of people tell me that, like, how do you get your same spot? And I'm like, I don't know.
Yeah. Yeah. We won't get into that. If she wants to share what kind of car it is, she can later, but yeah, we won't. Okay. So, Kayleen, you're up. Going to use this formula. So help me label some things over here. What is the -4, 2 for us in this formula?
-14.
Yeah, what is this? So in terms of our formula, like, do we know what this is? What's y1 for us?
2.
2, right? So this right here is our y1. And then the x1 is the -4, right? Okay, and then what is this number?
This slope.
The slope, that's our m. Okay, so we have all that given to us. So all we have to do is just inject them into the formulas, right? Okay, so go ahead and let's continue. It's going to be y.
Y minus 2.
Y minus 2, everyone good? Equals, keep going.
Negative
3, parenthesis.
3. X plus 4.
Wait a minute, x plus 4, where'd you get plus 4 from?
Because the negative and negative.
Yeah, so you have to be real careful with this. This is minus, right? But x1 was what? Minus 4. So you're subtracting a negative 4. Let me put that in here. You're subtracting negative 4. And that's why it becomes plus 4. Okay? There we go. Now, do we all agree that this is a linear equation in 2 variables? Equation, right? 2 variables, linear, powers on these are 1s. So if I graph that, that's a line, right? That is a line. And actually, it's the line that goes through that point and has that slope. So this is kind of like where we started class today. I could have given you an equation and asked you to graph it. Now I give you some information about the line, and I'm asking you to give me the equation. Any questions on that? What if I then asked you after this to put this into slope-intercept form? What would I be asking you to do? If I told you at this point, okay, you have the equation line, but I want it in slope-intercept form. What am I telling you to do? What? Thought I heard it. What does slope-intercept form mean?
You're going to solve it for y.
You're going to solve for y, right? That's all you're going to do. You're going to take this and solve it for y. All right? I'm not going to ask you to do it right now, but I want to make sure we understand some language because it starts to get confusing. Point-slope formula, yes. This is not in slope-intercept form, but it is the equation of a line. All right, let's do something a little different. Right now I gave you a point and I gave you a slope, right? And from there it's pretty straightforward as far as getting the equation. Okay, what happens if I give you 2 points instead of the point and the slope? So for this one, if a line passes through -1, 4 and 7, -6, find the equation of the line in slope-intercept form. Okay, so what you have right here is a problem that I would ask you on a test, right here. I think this problem right here encapsulates a lot of the concepts, all right? So I'm asking you to all I'm giving you is 2 points on the line, and from that, I want you to come up with the equation of the line, and then I want you to put it into slope-intercept form. So that means at the end, I do want you to solve for y. All right, so how are we going to get this? Yes?
Do we just put like y, or do we have to put that as well?
Do you have to do
Like,
y?
If you have that question, do we have to do the Pointslope formula also?
Yes, because you can't get, right now, you can't get to the equation of the line unless you use that formula.
But like, will you have a graph or
No.
no?
No, I mean, you could graph this though, right? We could, if we want, draw this. Let's just say we did that. Let's say we said, okay, I'm going to go -1, up 4, 1, 2, 3, 4, right? There's 1 point on the line, then I go out 7, 1, 2, 3, 4, 5, 6, 7, then go down 6, 1, 2, 3, 4, 5, 6. There's another point. I know this is the line, right? So, we're being asked to come up with the equation of that line and make sure it looks like y equals mx plus b at the end. But if you draw it, that's not going to necessarily help you come up with the equation, right? So we know how to do this, right? If I give you a point and a slope, previous problem, you can do it. But what if I give you 2 points? You can't, right? It's not the same problem. It's slightly different. What we need is 1 point and a slope. We have 2 points. So maybe there's a way to get the slope. Maybe we can get the slope through these 2 points. You can see it, like if we draw it, you can see the slope here, can't you? Can you see the rise over run here? Like how far down do we go and how far over do we go? Well, that would be your rise, right? That's your rise. And that right here is your run. Yeah, so yeah, you have to figure out what that distance is, and you have to figure out what that distance is. But instead of drawing it and trying to figure out the distance, we have a formula for it. We have a formula that allows us to find the slope without having to draw the picture. Does everyone understand that we could do it with the picture? All right. So here's the formula. So right now at this point, since we don't know how to do this, leave this formula here. I'm going to give you your second formula. This formula right here says given 2 points, we'll call it x1, y1, and x2, y2. So if someone gives you 2 points, x1, y1, x2, y2, so here they are, x1, y1, x2, y2, then the slope, okay, m is the slope, is always going to be y2 minus y1 over x2 minus x1. So it's the difference of the y coordinates divided by the difference of the x coordinates. Okay, so these are the 2 formulas that you are going to have to remember. And when I was a student, and I still am not good at memorizing things. What I would do when I had to memorize formulas is I would just sit there and look at them, and then when the test started, I would put them away, and as soon as the test got in front of me and they said go, I'd write the formulas down on the test, which is completely okay with me, all right, if you do that. And then I will also give you the option of having a formula sheet that you make, but remember there's a little penalty for that, so you have to make some decisions. Can you memorize these 2 things, or do you need to write them down yourself? All right, so with those 2 formulas, we should be able to do this now, right? Yes? Okay, so let's move through these. I think it's Itzel, right? Did I do that good? All right. All right, Itzel. So I've said that if someone gives us 2 points, that we can find a slope, right? And we already know that if we have a point and a slope, we can find the equation. So what should we go and do first? Okay, into where are we using this, or we use this one? Yeah, we're going to find the m. So we're going to do that first. We can get our slope, right? So let's do that. When I do m here, you're going to do y2 minus y1. So over here, we should probably label these how we want them. So do you want me to do like x1, y1 on the top one? Yeah, x1, y1 here, x2, y2 here. And then go ahead. You can tell me what I need to write here. So we're going y2 first.
It's
-6. Take away 4 over 7. Take away -1, right? So that's going to wind up being a plus on the bottom. So the top is -10, and the bottom is 7 plus 1, that's 8. And that is our slope, but we can reduce it, right? We can reduce that fraction, -5/4. Rodrigo? Where's Rodrigo? Rodrigo, you following okay with this? You're okay with this? So Rodrigo is a bit of a, you don't like to conform, right? You like to do things your own way. You don't like to listen to people. You're like always against, right? I'm making this up. But, so Rodrigo comes in here and he says, you know what? I'm going to call this x2, y2, and I'm going to call this one x1, y1. Right? So he flips them because he doesn't like to listen to what people tell him to do. So is he going to get the answer incorrect? If he Because I called that x1, y1, this one x2, y2, right? That's what I did. Rodrigo decides to do it this way. So is he going to get the wrong answer? Let's see. If he does it that way, what's his slope going to be? Rodrigo, what's your y2? 4, and then take away what? -6, right? And then the bottom x2 is -1, and then you're going to take away from that what? 7. Okay, so the top is 4 minus minus is plus, so 4 plus 6 is 10. And on the bottom you get -8. Are these the same answers, Rodrigo? Yes, they are. Okay, remember I just talked about this. The negative on top or the negative on the bottom is the same number. So the way you can look at this, let me simplify this. This is 5 over -4. Is this person is going to start at a point and then go which way? Down 5 and then to the right 4. The other person is going to do what? Start at that point and go up 5, left 4, and those both lay on the same line. Down 5, let's say we start here. Down 5, 1, 2, 3, 4, 5 over 4, 1, 2, 3, 4 is the same as up 5, 1, 2, 3, 4, 5 over 4. Those all lie on the same line. Okay, so you can't get it wrong. You just got to make sure that you choose which one you want to call x1, y1, x2, y2. And don't put the x's, you can't flip that. If you flip that, it's over. All right, you can't put the x's on top and y's on the bottom. All right, well, let's go back. We're going to not do Rodrigo's way. We're going to do this way. So this was x1, y1. This is x2, y2. All right, so we started with the 2 points. We got the slope. And now, Kiana? That's right? Okay. All right, now what, Kiana? This was gone. We have a slope, right, of our line, and we have actually 2 points. So can you come up with the equation now? What would we use to come up with the equation if we have a slope and 2 points?
So the slope would be b, right?
Well, what formula are you going to use?
Y equals mx plus b.
So y equals mx plus b is what our eventual answer wants to look like. The reason we can't use this one right now, though, is because we don't know what b is. We don't know what the y, because b is always the y-intercept. We don't know the y-intercept. All we know is the slope, right, and 2 points. So just think about that. Point, slope, right? Point, slope. So we want to use this formula, the point-slope formula. Once we use that, then we can get it to this, okay? So with that established, Kiana, if we use this, do you know what x1 is?
-1.
Okay, and then we know y1?
4.
4, and do we know the slope? So we just calculated that, right?
It's -5.
-5 over 4. So we're just going to plug those numbers in, and we will have the equation, right? Okay, so I'm going to do this now. Y take away 4 equals m, -5/4. Then x take away -1. So that's just plugging all our information in. By the way, could we have used this point instead of this point? Like Rodrigo would have had x1, y1 here, right? It turns out that either way, in there, you get the same line. Okay, so you don't have to worry about making that mistake. Yes?
So when do we use the y2 minus 1, 1?
We use that to get the slope. Okay? Once we have the slope, we go back to this formula, because all this formula requires is 1 point and a slope. We have 1 point, we have 2, but we don't need both. We just need one of them. And then we have the slope. Okay? So, are we done? No, because I said here I wanted it in what form? Slope-intercept form. So you have an additional step now. You have to go solve for y. So I'm going to keep cleaning this up. All right. Victoria? Where's Victoria? Okay, hi, Victoria. If you had to solve that for y, Victoria, what would you do first? At that point right there, what would you do?
I would move the 4 over.
You'd add 4? Okay, so everything else on the right side, I'm just going to leave alone? Okay. So if I take y, we add 4 to both sides, you'll get negative 5/4 parentheses x plus 1, and you added 4 to both sides, right? So you're going to go plus 4 out here on the side. Now, does that look like y equals mx plus b? Does it look like this yet? No, because you have a parenthesis around that x plus 1. So you need to get rid of the parenthesis. So how would you do that?
Well, I distribute.
Distribute. Okay, so oh, did you distribute before you moved the 4? Or
No, I moved
okay.
4 and then I-
Okay, so you distribute. You could do it either way. I'm just curious. Okay, so you have to distribute that through. Minus 5/4 plus 4. So negative 5/4 times x is negative 5/4 x. Negative 5/4 times 1 is negative 5/4, and then you still have plus 4. One last step. We almost have y equals mx plus b. We have y equals mx. So combine these together. And how do we put those together? You have to have a what? Common denominator. Right? So over here on the side, remember what you need to do is you need to do negative 5/4 plus 4 over 1, which is negative 5/4. 5/4 plus, what's that? Multiply top and bottom by 4, 16 over 4. So getting a common denominator, and then adding those together, and you should get what when you add those? 11 over 4? And now we are done. Someone gave us 2 points, right? And when we got those 2 points, we were able to establish the equation of the line that goes through those 2 points. All right. Yes?
We have gotten rid of the fraction before.
Before which step?
Like before transferring the 4. So when it was like y minus 4.
Oh, when it was y minus 4 equals that part right there, could you have gotten rid of the fraction? You mean like clear the fraction?
Yeah.
The reason you wouldn't want to do that is because if you, let's say you multiply by 4 to clear this, right? To clear that 4 out, you have to multiply this side by 4. And then what's going to happen is you're going to have 4 in front of the y, and then you're going to eventually have to go divide out by 4 because the whole idea is to solve for y. So you're going to wind up kind of like undoing what you did. So it's not like in the previous problems where we cleared the fraction so we could solve for y. Here we've already solved for y almost at that point, so let's not worry about, just work with the fractions. You have no way around the fractions. Like in a problem like this, you have no way around it. Okay. You all look thrilled, I can tell you what. All right, let's talk about the next topic, which everyone seems to really like this topic. I'm kidding. Parallel and perpendicular lines. All right, so let's see here. I'm going to ask these last few students. Let's talk about parallel lines first. Becca? Becca? If you were trying to explain to somebody like what parallel lines are, can you like just, like what, how would you explain it? They're, yeah, okay. Yeah, I mean, okay, so they're like the same something, right? So are these parallel?
Yes.
Okay, right? So, Stephanie? Where's Stephanie? How would you explain it?
Say that there are 2 lines
That
that never touch.
never touch? Yeah? What do y'all think of that explanation? Tiana? No, wait. Tiani. Tiani. Okay, right? All three in a row. That's kind of weird that those three sticks. Okay, so parallel, are you happy with the two?
Yeah. I was
Anything you want to add?
Yeah, but they never touch.
That they never touch. Do y'all like that definition? Two parallel lines are two lines that never intersect? You're kind of shaking your head. You're okay with that? Yes? So let me jot that down. Two parallel lines never intersect. I'm going to put a question mark next to that. Because that seems to be the definition that everyone seems to be happy with. Yes?
What if you had a third dimension?
A third dimension?
Yeah. Well, because if you have up and down, yes, they never intersect, but you could still, if you had another dimension to it, you could have them where they don't actually intersect, but at the same time, they don't.
I think what you're saying is if I have two lines on a flat sheet of paper, like this, that to be parallel means that they can't do that because they'll intersect somewhere.
Correct.
I think what you're saying is that if we're in three-dimensional space and move this one out a little bit, then they are obviously not parallel, but they're not intersecting either. Is that what you're saying? Yes, I would agree with that. So let's fix that, and let's say we are just talking about being on a flat sheet of paper. If we're on a flat sheet of paper and draw two lines, then parallel means they don't intersect. So does that help satisfy your... I like that. I do. I like that a lot. Because I want you all to consider something else. I'm putting this up here for a reason. Have any of you taken like an art history class or history, art, I don't know, basic art class? No? Okay, so most of you know this, right? Have y'all seen cave drawings? You know, from thousands and thousands of years ago, what human beings were drawing on cave walls. Would you say that they were artists? Were they good pictures? Were they more like kindergarten pictures? I mean, I don't want to criticize them too much, but I mean, cave drawings were pretty much like...
I think they're a little better than that.
Excuse me? That's a pretty good stick man. I'm sorry. That's a pretty good stick man. Yeah, no, I agree. They're better than that, but they still lacked some.
Tills?
Yeah. So I'm not a good artist, so that doesn't look like a human being. It doesn't look like, right? So how could I draw better? So what humans realized, and mathematics helped us do this, is that sometimes these rules make sense and sometimes they don't make sense. So I'm going to try and illustrate the point I'm trying to make. Right now the class seems to be happy with this. I'm going to draw for you a road, and I'm going to draw a couple of buildings on the side of the road. It's kind of like I'm looking from the top down onto this road. Everyone see it? And there's a lot of parallel lines here, right? Like this line right here is parallel to that line. And those are parallel, right, to the road. The dots are all parallel. All those are parallel, aren't they? And would you say that's a pretty good drawing of a road? Is that a pretty good drawing of a road?
Yeah.
Not bad? How could I do better? I could probably do better if I did this. Right? So this is starting to look a little bit better. Right? Ay, messed that one up. You get the idea, I think? So why is this one better? It looks more three-dimensional, right? So I'm tricking my eye into seeing depth, right? It's very difficult to trick the human eye to see depth on a flat sheet of paper. So if you follow all the rules and you're trying to draw a road, you'll be like, well, the road has two lines and they are parallel